So, good afternoon, and this is the last talk of this session. First, I would like to sort of thank both Sati and Arun for asking me to talk about this. And I felt I could say to myself, like the old Virginia Slims advertisement, you have come a long way, baby, because I remember that 20 years ago, we had first informal discussion of women in science the day before the main meeting or annual meeting of the academy began in a small room in IIT Guwahati guest house with about 10 or 15 people present and people asking whether the subject of women in science needs a discussion, whether this is something that is relevant for science. So I think I'm happy that today I'm giving this talk in a regular meeting of the academy, and I'm very happy that the subject has moved and its importance has been appreciated. So that's the first point. What I will try to first relate my topic to, of course, the theme of the symposium, that is role of gender equality as an indicator and as well as facilitator of development. Then I will specialize to the case of gender mainstreaming in science and give sort of a snapshot of status of gender inequity, as I call it in India, and the desirability of equity. And then I will try to be very brief about causes. There are two types of causes, some are obvious and some are hidden. And I would like to focus on the hidden ones, and those are the ones what is generally goes under the name invisible and unconscious bias. And then very briefly, I would like to kind of make some comments about the action plan, because 20 minutes is not a time period where you're going to be discussing these things in somewhat more detail threadbare. And last but not the least, I want to particularly comment about what the academy and the fellowship can do in the context. So the 17 Sustainable Development Goals that were put out on 2015. The goal fifth goal is gender equality, and the list goes on. It was shown in many talks. Now here I want to sort of make a few comments about gender parity and development. So there have been a lot of discussions in literature, the studies about how gender parity affects development. And this was a very recent report from McKinsey Global Institute, which was reporting on COVID, effect of COVID and on development and economy, etc. And what they showed is a very interesting plot. They had three regions, I think it was UK, Japan, and I forget the third country, in the three countries. And what they had a model, of course, and they calculated and showed that the current, gender parity in the workforce is about 0.61, and if you increase it from 0.61 to 0.67, it will lead to increase in GDP by $9 trillion. And if you can manage to change it to 0.71, it will lead to increase by $14 trillion. So these are the kinds of studies that people are doing, and these are kind of the relationships between gender parity and development. So this is not something, it's not the main focus of my talk, but at least this tells you specifically why gender parity or inequality, as they call it, is a sustainable development goal. But another thing, if you look at all the 17 goals, you will realize that mainstreaming gender in all walks of life is essential, not just for the development and the workforce, as we call it, but in general. And more importantly, the point that I would like to focus here is that let us understand that it is not for the sake of social justice that we are thinking of gender parity. We are thinking of this not for bettering a lot of poor women, that is of course there, but equally importantly, it is for the sake of development, and it is said much better by none other than Amartya Sen, whom I will refer on the next slide. So what happens is that gender equity, I call it equity, but I will explain why in science I think of equity and not equality. But gender equality feeds in positively in achieving a number of other sustainable development goals also. There is enough evidence that the climate action actually benefits positively because of the increase in gender parity in the action. So this is much more than just the goal number 5 of the SDG. That's all I want to say here. Here, as I said, there is this words of the master. I found them very interesting. This was in a foreword to this book, Women, Development and the UN, and this was written by Amartya Sen, that the focus of women's movement initially of the UN was mainly on women's well-being, and that's understandable. However, over the years, the objectives of women's movement have gradually evolved and broadened. Welfare is focused and no longer is treated as the passive recipient of welfare enhancing assistance, or women are increasingly seen as active agents of change and as dynamic promoters of social transformation that can alter the lives of both women and men. So this is the relevance of women in general, and I think the thesis that I would like to make is translate this also to women in science. Of course, the subject of gender parity across all walks of life is an extremely wide subject, nor do I have the expertise or the time to talk about it. And the audience here is audience of scientists, so I would talk about women in science. So, in general, basic science progress impacts development in many different tangible and intangible ways. And to the extent that the gender inequality impacts progress of science, a discussion of gender inequity in science belongs very much in the theme of today's discussion, only in the context of women in science, not necessarily in the development. And I would like to this is one of the messages that I would like to actually people to take home. Just like Dr. Amartya Sen said, do not think of actions of this academy, for example, bringing in equity or reducing the inequity of women in science as only as help to women for realizing their potential and for realizing their dreams, but think about also the impact of reducing the inequity on the processes of promotion of science itself, which is clearly one of our goals. Why do I say this? I say this because the way we react to the actions that we propose or we look at the efforts that we put in actually get colored by what we think the action is for. So I think it's very important to realize this. So already this was clear in the presentation and the numbers that were given by Professor Ramasamy, that indeed in the Manak program, even today actually, the fraction of girls is quite large, whereas by the time we come to the Inspire faculty fellowships, for various reasons, the number go down. So this is what is being sort of shown here, is that the fraction of girls, I have begun here from undergraduate, you see that the fraction of women in undergraduate, master, PhD is actually substantial. And this is the story of last 35 years. So this is not the data from last 5 years or 10 years. However, the big fall in the Indian case comes after the PhD when you go to postdoc and young faculty. That is really the sort of the story of the Indian women in science. And I have taken this, I can go back and look at all these different reports that came out. First time the report, INSA report. So there are these various sources, and they are all available on Women in Science webpage of Indian Academy. So I invite you, if you are interested, to look at them. Then here, this was a report that myself and Ram Ramaswamy wrote for the Women in Science and Technology in Asia. This was about 2015, 2016. Then we actually had also this survey done about why trained women leave science. So this is also there on the Academy's webpage, and all the numbers that I'm telling you can be substantiated. And most importantly, the last 5 to 6 years, I have only put 3, but this All India Survey of Higher Education have provided a lot of information on women in education. Now there are two different aspects, and I want to actually separate the two. That in India, the participation of women in studying science, or for that matter in teaching science, at all levels is actually not low at all, in fact. However, number of women doing science is certainly not commensurate with their participation in other two aspects of the scientific activity. And that's a fact of life. Numbers are telling us that. We didn't have these numbers very long time back, but now we know for sure that these numbers are an accurate representation of what's happening. And actually the fraction, the representation becomes less and less when one country considers decision-making positions in the context of science, in policy-making decisions for science. I like to say that the number of women in science in India is not small, but number of women in Indian science is small. And that is the point that we need to think about. So how do we compare with the rest of the world? Are we so unique? Actually not. But we are really at the lower end of the scale. This is the data from UNESCO Institute of Statistics, and you see that women in research world average is at 30%, India is at 15% in the lowermost column between 0 and 30%, and we are right at the bottom of it, the middle of it. But the rest, many other countries which are much better than that in terms of women in research. This is actually UNESCO gave this data interestingly, and this 15% matches with the 15% that I showed you in my earlier slide. So, devil is also in the detail. When you look at the education and look at the IISc reports, you find that the share of female students is lowest in the institution of national importance, followed by the deemed universities and the government and then state private universities. It goes continuously from 24.7% of national eminence to 43% in state universities. Also, if you look at gender ratio in faculty, it's gets skewed as the institution's perceived level of eminence increases, and also the position in the hierarchy. As an example, in professor's position from this end now, the state private university to national institutes of national importance, the percentage falls from 24% to 15%. So, fractions of women professors, directors, deans, VCs is far from equitable, and it's certainly not even commensurate with the small fraction that is present in the research and research institutions as well. About women's presence in the fellowship and awards is, I can just say, is strikingly low, and to be honest, the numbers are so small that it doesn't make too much sense to talk about percentages, because all I can say is that the first woman fellow of the Indian Academy in physical sciences was selected in 1992. Today maybe we have 10 women fellows, so we can say the numbers has increased by thousands of percents, but every time it's only 1% or within 5% of the total fellowship. So therefore I will not really spend too much time on this, but this is the thing. Now you can say, is it necessarily bad? People are doing pretty well. I mean, Dr. Ramasamy showed us we are increasing it. We don't know about quality, but numbers are increasing, we are doing well. So what does it matter? If women don't contribute, women don't contribute. We should just go home and be happy that we are moving well in science. But actually I think it's necessarily bad because it's a matter of judicious utilization of available resources. It's like saying that you're putting half your capital in the safe and not using it. And particularly because diversity can only be good for progress in science, just as it is true for any creative activity. So it is not that somebody should be given a chance to do science because she is a woman, but because she is a different person. She brings different perspectives. What science we do seems to depend on who we are. In fact, there is social science research, and I will not discuss it, which actually seems to now support that diversity. I am not even talking just of women. Diversity in the workforce seems to lead to better science, but that's a matter for debate for another day. But this is what it is. So we know that, so this is the first point that I want to make, that let us not think about achieving equity for women in science as a matter of charity to women. Please don't think of it like this. Think of it, this is something that we need to do for good of science. And after all, propagation of science is my mission as a member of this academy. So I think it is important because how we look at the subject changes. What we do about it changes, because our perspective changes, our approach to handling this as a problem. Is it my problem? Because I can tell you, after my experience of last 20 years, that most of the people seem to think that this is the problem of women and to be solved by women. And I don't think that's quite fair, because this is not the problem of women. This is a problem of science if we accept the fact that diversity makes science flow better. So in India, I would say that in general, of course, in the world over, we are always thinking about development of human resource. But in India, in the context of women, it's also a problem of human resource deployment. I mean, think of it very pragmatically. The efforts that are put in, I have heard many of my colleagues saying, oh, I don't want to take women students because they get married and they leave. But then think of the woman herself who invests her time, her energy, and the advisor, and the government which is investing the money. And then if they fall off the cliff, all that investment has gone for nothing. It has gone waste. So it's a very pragmatic thing that we should try and see how we can, plug this brain drain at the. So it's something that we need to, all of us need to worry about. It's easy to see lack of diversity and equity in science. I can give you many numbers. I can spend a lot of time on that. I also argued indirectly why this needs to be cured. Now, how to cure things and how to judge what level of diversity and equality is correct? Are we going to be okay when we say 30% of the women are faculty, 30% women in the decision-making bodies? I don't think these questions are as simply answered. And other important thing is that lack of numerical representation that we see is a symptom. That's not the problem. We have to try to understand what are the problems, what are the root causes, and try to discuss this further. So in general, what are the reasons? There are some very obvious ones, some already mentioned in the answer and the discussion following the earlier talk. And in India, I think I'm happy to know and say that a lot of discussions have happened mainly on how one can handle the obstacles that are put in because of the obvious causes. And actually, I'm quite happy that the Indian governmental system at least has been very proactive about it. But let's anyway go and see what are the reasons. So there what I call is the ticking clocks. The body clock is ticking right after you finish your PhD. Of course, you want to start a family. There is not just pressure, but there is also desirability of starting your family young. But it is also the time, if you want to make a career in science, you need to develop your own niche. You need to start working on your own ideas, and you want to say, this is me in science. And for women, these two clocks, what I call clock of science and clock of the body, actually are ticking simultaneously. So this is a problem that is specific to women. And therefore, solutions have to be thought about for women in the early period. Perhaps we need to think about this. And those are what I would call, oh my God, I am not even going to halfway through. And the second one is negotiating career and family balance. And that is obvious one, that is for all women who want to go and work. So the perception is sort these problems out and all will be well. In India, as I said, we have policies which exist to come back to a career after a break. There are policies for flexi time. There are, we do programs for encouraging young girls to choose S&T. We hold training programs for women scientists to take leadership roles. All that is extremely fine. They are necessary, but they are not sufficient. And that brings me to the subject which I wanted to focus on a little bit, where I wanted to show you some data, and that is invisible and unconscious bias. Now, these are biases about a woman, what a woman can do and cannot do. Biases about a woman, what a woman should do or what she should not do. And it actually impacts the mentoring we give to our young students. Imagine a couple who is working in your lab comes together, and the boy has got maybe a good job and the girl has not yet, her dream job is in some other city. And then many of us would say, why don't you try to find a soft money position? That happens. And this mentoring we do out of well-being, thinking about good of the couple. So think about that. That's an invisible bias. So it can directly impact the number of women that stay in S&T and what they can achieve. And I would say that in some sense, after my experience of 35 years, that almost all of the unconscious invisible biases arise from the the lack of importance or the low importance we attach to participation of women in science, both in the eyes of society and scientists. I will not exclude scientists from that. So I am going to give you 3 examples of unconscious gender bias in Hierarch. This is a classic paper by Corinne Moss and Roxen. Another unconscious bias in evaluation. And why these 2 are important? Because we as scientists, we pride ourselves to be a meritocracy. We make our decision based on quality. Now these 2 researches that I want to show you, how you see that in spite of that, if we want to be really a meritocracy, we need to really get them decided by merit alone, and I want to show you 2 examples where that has not happened. So this is actually a description. This is a PNAS paper. They did a double-blind study. They took their number was 127 total number. They took the science faculty from research-intensive universities, and they were asked to rate applications. And the applications were randomly, same application was randomly assigned a male or a female name. And they asked what is the higher ability, how willing you will be to mentor the student, and what salary you would pay. And on competence, on higher ability, on mentoring, the identical male application consistently received higher rating, and it was beyond 3 sigma. Though it was not the gold-plated 5 sigma that particle physicists like, this was good enough. Okay? Then there is another one very classic study by Wenderas and Bolt. Here these are actual selections for a postdoctoral fellowship of the Medical Research Council in Sweden. They were surprised that there is such a big 57% women are in biomedical physics, but in the faculty there were very few. So they asked this question, and they actually got the data from the selection committee under some act of information, the freedom to information. And this is very interesting. The x-axis is the impact simply constructed out of the impact factor of the journal you published and the number of papers you published. As meritocratic as you can think it to be. Consistently they found there were some, I think the number was 62 and 50 men and 57 women. So reasonably equal numbers. The score, competence score that was given by qualitative score by the committee was for the same productivity 2.6 and 2.4. In fact, they do more multiple regression analysis and so on, and they actually show that a female applicant had to be 2.5 times more productive than the male counterpart, average male counterpart. Now this is invisible bias. This is unconscious bias. Then there is another important thing, that there is a recent investigation, not so recent, 10 years back, gender differences in the reception of results on research and gender bias. Here they found that they used both general public and university faculty samples, and they saw that men evaluate the quality of research unveiling gender bias as less meritorious than women do. On the other hand, they did another trick. They changed the abstract and they said that there is no gender bias, and then women tended to rate it as less meritorious and men tended to rate it as more meritorious. Even more interestingly, the non-STEM faculty never thought that they had acceptance of the result, statistical numbers given by p equal to 0.001. They said, yes, this is significant difference. So the non-STEM faculty also seem to agree with the fact that there is this invisible bias. So all I'm trying to say is that this is a very, and I want to end with this, is that I want to quote from a book of Women in Science Writing the Record. Asimov in 1976 brought out a biographical encyclopedia of science and technology. It had 1,195 men and 10 women. And out of the 10 women, 5 were Nobel Prize winners. Of course, half of 1,195 were not Nobel Prize winners. I mean, you can draw two conclusions. The first reasonable one, which I will draw, is that the bar for women to be included was incredibly high. But I can also draw a conclusion that women are very small in number, but they are just so incredibly smart that half of the women in science win only Nobel Prizes. So the point is that there are these biases. There is this last one which is very, very interesting. is that there is a person called Ben Barres. He wrote a comment in Nature called Does Gender Matter? And he actually, he says, shortly after he or they, shortly after I changed sex, because he was a transgender, shortly after I changed sex, a faculty member was heard to say, Ben Barres gave a great seminar today, but then his work is much better than his sister's. So we actually, all this I'm trying to tell you is that even though we think that there are no biases, there seem to be these. We need to analyze them. We need to understand them. And as it happens, this was also something that we saw in our own survey. When women who left science, we asked them, did you leave because of family? They said yes. Some of them said yes. But some of them said they left because of the attitude, the responses they got in trying to continue with the family. So, now the story can go on. I mean, I don't want to do this, but there are a lot of examples of invisible and unconscious biases that we can keep on discussing. But the whole point, therefore, is, that's why I said I can keep on giving examples, but I think what happens at the end of the day is there are two things. First, at an individual level, we need to introspect. We need to ask questions because it depends on our biases, depend on our experiences. But even more importantly, I think when we make policies, and many of the academic fellows, section heads, department heads, library, lab heads, we need to, when we sit making policies, we need to be aware that there are these issues and we need to think about them. I want to ask here one question. Last year, Partha very nicely allowed the Women in Science panel to screen a film called Picture a Scientist. I want to know how many people saw that film. This was made available by the Academy for a period of 12 days. So that just shows how much interest we take in the subject. And I'm trying to tell you that please change your point of view. This is not a story for women and by women. So, I think right now I am very happy that STEEP 2020 actually has a equity and inclusion chapter. I really don't know when those draft policies will ever become policies and when they will come to us as policies. But my appeal to all of us, the academy fellows, the directors among you, the heads of the departments among you, don't wait till those policies come down and the government says, these are the policies you must enact. Why don't we think for ourselves? The last women, as I said, we have actually drafted a statement about gender equity and we actually had drafted an action plan. Again, my second question. This was sent as an email by Professor Partha to all the academic fellows. I want to know how many people even opened the document. I mean, again, please don't think of it that this is something, these crazy women are sitting there and doing something. This is something that is important to all of us and we must think about it. The time has really come. We need to walk the talk. I mean, even this summer I could identify in the acceptance letter to one of the summer students, which I had to take, an assumption that a generic summer student possessed only the Y chromosome. So I think we need to be, really need to worry about it. And as I already said, I want to appeal to the fellows of the academy who are in position of authority to do something, and they are still mostly men. Be alive to this problem of unconscious bias. Think about how we can change our selection processes. Think about how we can identify these invisible biases. And that's really all that I have to say as an appeal to all of you, that in order to reach a gender neutral situation, we need to be actively aware of gender differences for quite some time. Thank you.